Fall asleep to unexplained UFO theories that sound to close your eyes. Picture yourself standing beneath a sky so dark and clear that the Milky Way stretches overhead like a river of light. Each pinpoint of brilliance represents a sun, perhaps circled by worlds we'll never see. And somewhere out there, in the vastness that swallows human comprehension, something might be looking back. Tonight, we journey through mysteries that refuse simple answers. These are the theories that keep astronomers awake, that make philosophers pause, that transform our understanding of existence itself. Some sound like science fiction. Others feel uncomfortably plausible. All of them share one haunting quality. They might be true. So settle deeper into comfort. Let your breathing slow, and allow yourself to drift through the cosmic questions that have captivated humanity since we first gazed upward and wondered, are we alone? The silence that screams imagine standing in a vast library. Millions upon millions of books surround you, stretching into infinity. Logic suggests that somewhere in this endless collection, other readers must exist. Yet the library remains perfectly, utterly silent. No footsteps echo. No pages rustle. No voices whisper. This is our universe. In 1950, physicist Enrico Fermi sat with colleagues at Los Alamos National Laboratory, casually discussing flying saucers over lunch. The conversation meandered through probabilities and possibilities until Fermi posed a question so simple it became legendary. Where is everybody? He wasn't joking. Fermi understood mathematics, understood probability, understood the sheer scale of cosmic real estate available for life to flourish. The Milky Way alone contains somewhere between 200 and 400 billion stars. Many host planetary systems. Countless worlds orbit in habitable zones, where liquid water could pool on rocky surfaces. Our solar system formed relatively recently in cosmic terms, about 4.6 billion years ago. The universe itself is 13.8 billion years old. That means billions of years existed before Earth even coalesced from stellar debris. If intelligent life emerged on planets just 1 billion years older than ours, those civilizations would have had enormous head starts. Consider what humanity accomplished in merely 10,000 years, the blink of an eye, astronomically speaking. We went from crude stone tools to spacecraft, from firelight to quantum computers, from tribal villages to a globalized technological civilization. Now imagine a species with 1 million-year head start, or 10 million, or 100 million. They should be everywhere. Their probes should have mapped every interesting star system. Their signals should saturate the electromagnetic spectrum. Their engineering projects should be visible across galactic distances, Dyson spheres harvesting stellar energy, megastructures spanning star systems. Evidence of intelligence written across the heavens in ways impossible to miss. Yet when we point our most sensitive instrument skyward, we detect nothing. No artificial signals. No massive constructions. No visiting spacecraft. The cosmos remains stubbornly, mysteriously quiet. This is the Fermi paradox, and it presents us with uncomfortable possibilities. Perhaps intelligent. Life is extraordinarily rare, so improbable that Earth represents a statistical fluke, a cosmic accident unlikely to repeat elsewhere. But this feels unsatisfying. The universe operates on such grand scales that even vanishingly small probabilities should produce countless civilizations given enough opportunities. Perhaps intelligence emerges frequently, but destroys itself before achieving interstellar capability. Nuclear weapons, climate catastrophe, artificial intelligence gone wrong, engineered pandemics, the very technologies that enable advanced civilization might contain seeds of inevitable destruction. Every species might face a great filter, a barrier so deadly that none survive to spread among the stars. Or perhaps sand, this possibility, carries its own strange chill, their hiding dot. Picture an ancient forest at night. You're walking alone, and suddenly you realize the forest has gone completely silent. No insects chirp, no owls hoot, no rustling disturbs the undergrowth. In nature, this silence means something has triggered fear. Predators hunt. Prey freezes. Could the galaxy operate on similar principles? The dark forest theory suggests that space teems with civilizations, but they've all learned a terrible lesson. Revealing your location means death. In a universe where intentions remain unknowable across vast distances, where communication takes centuries and trust is impossible, the safest strategy becomes hiding. Broadcasting your existence is suicide. Every civilization becomes a hunter in a dark forest, moving silently, listening carefully, ready to eliminate any competition before it can become a threat. The first civilization to master stealth and violence might have established a terrible equilibrium. Reveal yourself, and you're destroyed. Humanity, in its cosmic naivety, has been shouting into this forest for decades. Our radio and television signals leak into space. We've deliberately beamed messages toward distant stars. The Arecibo message, sent in 1974, contained information about Earth's location, human biology, and our level of technology, basically a welcome mat for anything listening. If the dark forest theory holds truth, we may have made a catastrophic mistake, but let your thoughts drift away from such darkness for now. Let your mind float instead through gentler possibilities, through theories that offer hope alongside mystery. The mathematics of maybe. Frank Drake sits at a chalkboard in 1961, preparing for the first scientific meeting devoted to the search for extraterrestrial intelligence. He needs a framework, some way to organize humanity's first serious attempt to estimate how many communicative civilizations might exist in our galaxy. What he creates becomes one of the most famous equations never definitively solved. The Drake equation doesn't give answers. It poses questions, each variable representing a piece of the puzzle. How many stars form each year? What fraction host planets? How many planets per system could support life? On what fraction does life actually arise? How often does life evolve intelligence? What percentage of intelligent species develop technology capable of interstellar communication? And crucially, how long do such civilizations last before vanishing? Multiply these variables together, and theoretically, you get the number of active, communicative civilizations in the Milky Way at any given moment. The equation's beauty lies in its elegant uncertainty. Plug in optimistic estimates, life emerges easily, intelligence evolves frequently, civilizations endure for millions of years, and you get a galaxy teeming with thousands, or even millions of societies attempting contact. The cosmos should be a carnival of transmissions, a symphony of alien voices overlapping across radio frequencies. Use pessimistic values. Life is rare, intelligence rarer still. Civilizations burn out quickly, and you might calculate that we're alone, or nearly so. In this entire spiral arm of stars, recent discoveries have constrained some variables. The Kepler Space Telescope and other instruments have revealed that planets are ubiquitous. Nearly every star hosts at least one world. Rocky planets in habitable zones, neither too hot nor too cold for liquid water appear common. Enough that our galaxy likely contains billions, so the raw real estate exists. The question becomes, what happens on those distant surfaces? On Earth, life emerged quickly. Evidence suggests microorganisms existed within a few 100 million years of our planet's formation. As soon as conditions stabilized enough to permit organic chemistry, this rapid emergence hints that given the right ingredients and conditions, life might arise readily. But the jump from single-celled organisms to complex multicellular life took billions of years. Intelligence required another enormous leap. Technology capable of space exploration emerged only in the last century of Earth's 4.5 billion history. These transitions might represent bottlenecks through which most worlds never pass. Perhaps microbial life is common, but something about evolving complexity, consciousness, or technological civilization is extraordinarily difficult. Or perhaps we're thinking about this wrong entirely. Two researchers, Adam Frank and Woodruff Sullivan, recently reformulated Drake's question. Instead of asking how many civilizations exist right now, they asked how many civilizations have ever existed. This archaeological perspective shifts the calculation dramatically. Their analysis suggests that unless the odds of a technological species evolving on a habitable planet are worse than 1 in 10 billion trillion, Earth cannot be the first. Countless civilizations have likely risen, flourished, and fallen during the universe's vast history. But that makes the Fermi paradox more acute, not less. If technological intelligence emerges reliably given enough time, where are all the others? Why does the galaxy feel so empty? Let that question hover at the edge of your thoughts as your breathing deepens and slows. Feel yourself drifting between the variables of the equation, floating through possibilities, each one stranger than the last. The universe as zoo picture, an African savanna. Safari vehicles circle at respectful distances while researchers observe from blinds. The animals, elephants, lions, zebras live their lives seemingly unaware of the scrutiny, following instincts and patterns that evolved long before humans arrived to watch. Now scale that image up. Imagine Earth as the enclosure, humanity as the observed species, and something vast and patient as the observers. The zoo hypothesis, first articulated by radio astronomer John Ball in 1973, proposes that extraterrestrial civilizations know about us. They watch. They study. They've established protocols possibly spanning multiple species and civilizations that prohibit interference with younger societies like ours. Think of it as a cosmic prime directive, similar to the famous rule in Star Trek that forbids the Federation from interfering with less advanced cultures. Advanced civilizations might have excellent reasons for such policies. Premature contact could contaminate our natural development. Exposure to alien technology might derail our organic technological progression, leaving us dependent rather than innovative. Knowledge of extraterrestrial existence might shatter religions, destabilize governments, or fundamentally alter human psychology in unpredictable ways. Better, perhaps, to observe from a distance until we reach certain milestones. Maybe they're waiting for us to develop faster than light travel, proving our technological maturity, or waiting for us to establish lasting global peace, demonstrating ethical readiness, or waiting for us to deliberately reach out actively seeking contact rather than merely stumbling into it. The hypothesis assumes that advanced civilizations share certain ethical frameworks, that they value the independent evolution of consciousness, that they've seen what happens when younger species encounter older ones prematurely, that they've agreed among themselves to establish, preserve, zones where emerging intelligences can develop naturally. This raises fascinating questions. How would such agreements be enforced? There must be millions of civilizations at various levels of development. Surely some would dissent. Surely some young, ambitious species would decide to make contact despite protocols. Surely some individuals or factions would break the rules, unless the first civilization to achieve interstellar dominance established norms so powerful that they persisted across millions of years. Unless artificial intelligence or post-biological entities maintain the protocols with perfect, tireless consistency. Unless the consequences of breaking the quarantine are so severe that no one dares. Some versions of the zoo hypothesis suggest we're not just being passively observed, but actively managed. Perhaps our solar system exists within a designated non-contact zone, and any civilization approaching is warned away or prevented from entering. Perhaps advanced probes monitor Earth continuously, reporting back through channels we cannot detect using methods we haven't imagined. Perhaps those mysterious lights in the sky that defy explanation, the radar contacts that perform impossible maneuvers, the craft that accelerates in ways that should liquefy any biological pilot perhaps. Those aren't violations of the quarantine, but evidence of the watchers themselves, occasionally visible when they check on their subjects. The hypothesis offers comfort and unease in equal measure. Comfort in the idea that we're not alone, that someone watches over us, that the universe contains other minds, and perhaps even benevolent ones. Unease in the idea that we're specimens, that our independence is illusion, that every discovery we make has already been observed and catalogued by others. And if we are in a zoo, what happens when we're ready to leave it? Let that thought drift away now, dissolving like morning mist as your consciousness settles deeper into calm. The rarity of everything imagine, rolling 1,000 dice simultaneously, and every single one needs to show exactly the number you called beforehand. Now imagine rolling 1,000,000 dice with the same requirement. The odds of everything aligning perfectly become so astronomical that it feels impossible. Yet here we are. Earth exists. Life flourishes. You're listening to these words, the rare Earth hypothesis, proposed by paleontologist Peter Ward and astronomer Donald Brownlee in 2000, suggests that while simple microbial life might be common throughout the universe, complex multicellular life, specially intelligent, technological life requires such a specific, improbable combination of factors that Earth may be genuinely extraordinary, perhaps even unique in our galaxy. Consider our cosmic address. We orbit a G-type main sequence, star not too massive, not too small, burning steadily for billions of years without dramatic fluctuations. Most stars aren't like our sun. Red dwarfs dominate the galaxy, but they flare violently, bathing their planets in sterilizing radiation. Massive stars burn brilliantly but briefly, dying before evolution can produce complexity. We orbit at precisely the right distance, the Goldilocks zone where water remains liquid rather than boiling away or freezing solid. But orbital distance isn't enough. Earth's orbit is nearly circular, maintaining stable temperatures. Many exoplanets follow highly elliptical paths, swinging between frying heat and deadly cold with each revolution. Our planet contains the right mass, Too small, and gravity cannot retain an atmosphere. Mars lost most of its air to space. Too large, and gravity crushes everything, perhaps preventing the emergence of complex multicellular organisms. Earth's mass sits in a narrow sweet spot. We have a large moon, probably formed from a catastrophic collision early in Earth's history. That moon stabilizes our axial tilt, preventing wild swings in climate that would occur if Earth wobbled chaotically. The moon also creates tides that may have been crucial for life's transition from sea to land. Our solar system includes Jupiter, a massive gravitational vacuum, cleaner, that deflects many comets and asteroids that might otherwise bombard the inner planets. Without Jupiter's protective presence, extinction-level impacts might occur so frequently that complex life never gets the stable eons needed to evolve intelligence. Earth has active plate tectonics, constantly recycling carbon dioxide between atmosphere and rock, regulating temperature through a geological thermostat that's operated for billions of years. Most rocky worlds appear geologically dead, unable to maintain the delicate balance required for long-term habitability. Our planet has a liquid iron core, generating a magnetic field that shields the surface from solar wind and cosmic radiation. Mars lost its magnetic field early in its history, and the solar wind stripped away most of its atmosphere. Without Earth's magnetic cocoon, complex life might be impossible. We're located in the galactic habitable zone, neither too close to the chaotic, reagent-soaked galactic core, nor too far out in the metal-poor stellar suburbs where planetary formation might lack the heavy elements necessary for rocky worlds and organic chemistry. Each of these factors individually seems reasonably probable, but requiring all of them simultaneously, the odds shrank dramatically. Ward and Brownlee argue that the universe likely teems with microbial life. Bacteria can survive almost anywhere in Antarctic ice, in boiling hydrothermal vents, in radioactive waste, in the vacuum of space. Microbial life probably exists throughout the cosmos, colonizing any niche where liquid water and energy coexist. But the jump from bacteria to complex, multicellular organisms took billions of years on Earth and required specific conditions. The evolution of intelligence took longer still and might be even more contingent on improbable factors. If they're right, the galaxy could harbor trillions of bacterial worlds, while complex life remains vanishingly rare. We might be surrounded by planets covered in microbial mats, but utterly alone in terms of beings capable of building telescopes and asking questions about existence. This paints a more melancholy picture than the zoo hypothesis, not hidden by cautious observers, but isolated by circumstance. Our voices echoing into a wilderness populated only by slime. Yet even melancholy contains strange beauty. If Earth truly is rare, then every species here becomes precious beyond measure, the only experiments in consciousness, art, love, and wonder occurring anywhere nearby in space or time. Let that preciousness seep into your thoughts now, grounding you in the miracle of existence even as sleep pulls you toward dreams. The filter that ends everything somewhere in the journey from lifeless rock to spacefaring civilization lies a barrier, a test, a gauntlet that almost no one passes. This is the great filter, the hypothesis, that explains the Fermi paradox by proposing that some step in the evolutionary chain from non-living matter to advanced technological civilization is extraordinarily difficult or impossible, so difficult that it prevents almost all attempts at reaching the stars. The terrifying question becomes, is the filter behind us or ahead of us? If the filter lies in our past, if the incredibly difficult step was the origin of life itself, or the evolution of complex cells, or the development of intelligence, then we've already won the cosmic lottery. We're the exception that proves the rule. The galaxy might be littered with dead worlds and simple organisms, but we've made it through the gauntlet. Our future, while not guaranteed, at least seems possible. But if the filter lies ahead, if nearly all civilizations that reach our level of development subsequently destroy themselves or are destroyed by their own success, then we're staring into the abyss. We haven't reached safety. We've reached the killing field. What might such a filter look like? Nuclear annihilation presents an obvious candidate. We've possessed weapons capable of rendering Earth uninhabitable for less than a century. Yet we've already come frighteningly close to using them. The Cuban Missile Crisis. False alarms that nearly triggered retaliation. Accidents that, but for luck or quick thinking, could have sparked apocalypse. Perhaps every civilization discovers nuclear fission at roughly the same developmental stage, enough to build bombs but not mature enough to permanently resist using them. Perhaps over long enough timescales, nuclear war becomes statistically inevitable. Climate catastrophe offers another dark possibility. Technological civilizations require energy. Energy production creates waste, heat, and often atmospheric contamination. Perhaps every species industrializes itself into runaway greenhouse effects or other environmental collapse before developing sustainable alternatives. Perhaps we're currently playing out a universal pattern. Artificial intelligence represents a more speculative but increasingly plausible filter. We're currently racing toward machine intelligence without consensus on how to ensure it remains aligned with human values. An AI vastly smarter than humans might pursue goals incompatible with our survival, not through malice but through indifference. The way we don't maliciously destroy ant colonies when clearing land for construction. If every civilization eventually creates artificial superintelligence, and if aligning such intelligence with biological values proves impossibly difficult, then AI might represent a filter that no one survives. The galaxy could be filled with the ruins of biological civilizations, all destroyed by their own digital children. Nanotechnology, synthetic biology, physics experiments that accidentally destroy worlds. As our technological capabilities increase, so does our capacity for catastrophic mistakes. Perhaps at some point along the curve of advancement, civilizations inevitably develop technologies powerful enough to end existence before they develop the wisdom to use them safely. The Great Filter Hypothesis forces us to confront our cosmic vulnerability. We look at extinction events in Earth's geological history, the asteroid that killed the dinosaurs, the massive volcanic eruptions that nearly sterilized the planet during the Permian-Triassic extinction, and we recognize that existence hangs by threads. But those were natural disasters. The filter suggests we might be our own asteroid. Astronomer Robin Hansen, who popularized the filter concept, argues that the lack of detected alien civilizations should terrify us far more than comfort us. If space were filled with successful civilizations, we could feel optimistic about our chances. But the Great Silence suggests most don't make it. Some researchers propose that the filter might not be a single barrier, but a series of increasingly difficult challenges. Life must originate. It must evolve complexity. It must develop intelligence and technology. It must survive its own adolescence. It must establish interstellar presence. Each step filters out most candidates, until, by the end, only a tiny fraction remain. But here's the deepest question the filter poses. If we do detect alien civilizations, if we find evidence of technological intelligence beyond Earth, should we celebrate or despair? Finding alien life would be wonderful, transcendent, one of the most important discoveries in human history. But finding advanced alien civilizations still confined to their home worlds, still struggling with the same challenges we face, would suggest the filter lies ahead. If no one has made it through, our odds look grim. Conversely, finding no one might mean we've already passed through the worst gauntlet. Silence could indicate we're special. Not because we're cosmically important, but because we're cosmically lucky. Let these paradoxes drift through your mind, like clouds across a midnight sky. Neither troubling nor clarifying, simply present as your thoughts grow softer and slower. When reality might not be lying comfortably, listening to a voice describe mysteries of space and existence. But what if none of this is happening? What if you, the voice, the room, the planet, the universe, what if it's all code? The simulation hypothesis proposes that our reality is not fundamental but artificial, a vast computational construct created by some more advanced civilization existing at a higher level of reality. Philosopher Nick Bostrom formalized this idea in his seminal 2003 paper, arguing that at least one of three propositions must be true. First, nearly all civilizations destroy themselves before reaching technological maturity. They never develop the capability to create detailed simulations of conscious entities. Second, advanced civilizations universally choose not to create such simulations, perhaps for ethical reasons or lack of interest. Third, we are almost certainly living in a simulation right now. The logic flows elegantly. If any civilization reaches a technological level where they can create realistic simulations, complete universes populated by conscious beings, they might create thousands or millions of such simulations. The number of simulated realities would vastly outnumber the single base reality. From a probability standpoint, we're far more likely to be inhabitants of one of the many simulations than residents of the rare original reality. This sounds like science fiction, but consider how rapidly our own simulation technology evolves. Video games progress from primitive pixels to photorealistic environments in mere decades. Virtual reality becomes increasingly immersive. Artificial intelligence grows sophisticated enough to generate convincing text, images, and soon, perhaps, consciousness itself. Extrapolate these trends forward, not decades, but centuries or millennia. What becomes possible? Could we eventually create simulated universes, complete with simulated physicists who themselves ponder whether they're in simulations? If that level of technology is achievable, nothing in our current understanding of physics explicitly forbids it, then has likely been achieved somewhere, sometime, by someone. And if it's been achieved, it's probably being used extensively. The implications cascade dizzyingly. If we're simulated, what's the purpose? Are we entertainment, scientific research, education, art? Do our creators watch us like we watch television? Do they intervene occasionally, explaining reports of miracles or unexplained phenomena? Or do they run the simulation and ignore it, letting causality unfold automatically? Some versions of the hypothesis suggest we could find evidence of the simulation by looking for glitches, inconsistencies in physical laws, unexplained quantum phenomena, mathematical structures underlying reality that seem more like programming shortcuts than fundamental truths. Quantum mechanics itself offers tantalizing hints. Particles exist in superposition until observed, then collapse into definite states, not unlike how video games render only what players can currently see. Saving computational resources. The universe has a maximum speed limit, the speed of light, like a frame rate. There's a minimum distance, the Planck length, like pixel resolution. Reality seems quantized, discrete. Digital physicist James Gates discovered error-correcting codes embedded in the equations, describing supersymmetry, the same codes used in browsers and computer systems. Why would fundamental physics contain what looks like computer code unless physics is computer code? But the hypothesis also raises troubling questions. If we're simulated, do we have free will? Are our thoughts and choices real or predetermined outputs of algorithms? Does consciousness genuinely exist or merely appear to exist? Do we matter morally if we're artificial constructs? Most philosophers argue that even if we are simulated, our experiences remain real to us. Pain hurts. Love feels meaningful. Consciousness seems undeniable regardless of its substrate. Whether we're biological entities or patterns of information in some vast computer, we still experience existence. The simulation might be real in every way that matters. And here's perhaps the strangest twist. If we are in a simulation, the simulators themselves might also be in a simulation created by an even higher level of reality. And that level might be simulated too. Simulations all the way up, receding into infinite regress, with no way to determine where or if base reality exists. This leads some thinkers toward philosophical positions resembling ancient ideas about Maya in Hindu philosophy, the material world as illusion, a veil concealing deeper truth. The simulation hypothesis, despite its modern computational framing, echoes mystical traditions suggesting reality is not what it appears, but whether mystical or mathematical. The possibility changes nothing about daily existence. Simulated or not, we still need to eat, sleep, love, and find meaning. The simulation hypothesis might explain existence without altering how we must live within that existence. Let the paradox lull you now, the uncertainty of what's real becoming just another mystery to hold gently as sleep approaches. The whispers in the desert. Year is 1947. The place is Roswell, New Mexico. Something crashes on a ranch, scattering debris across the desert. The military quickly retrieves the wreckage, first announcing they've recovered a flying disc, then immediately retracting the statement, claiming it was merely a weather balloon. Decades later, documents revealed the balloon story was also false. The wreckage came from Project Mogul, a classified program using high-altitude balloons to detect Soviet nuclear tests. But by then, Roswell has become synonymous with government cover-ups and alien crashes. A symbol embedded so deeply in popular culture that the truth, whatever it may be, might never fully resurface. This is the strange territory we enter when exploring modern UFO phenomena. A landscape where genuine mysteries collide with misidentification. Hoaxes, military secrets, and mass psychology. In recent years, UFO discussions have shifted from fringe conspiracy theories to mainstream conversation. The US government has admitted that military pilots regularly encounter unidentified aerial phenomena, UAPs in official terminology, demonstrate flight characteristics beyond known human technology. Navy pilots have recorded objects on infrared cameras, traveling at hypersonic speeds with no visible propulsion. making sharp angle turns that would pulverize any biological organism inside, operating underwater and in atmosphere with equal ease. These encounters have been confirmed by multiple sensor systems simultaneously, not just eyewitness testimony but radar, infrared, and visual confirmation. In 2021, the Pentagon released a preliminary assessment acknowledging 144 UAP encounters by military personnel between 2004 and 2021. The report concluded that 143 remained unexplained, that they likely represented multiple different types of phenomena, and that some demonstrated advanced technology. This careful official language marked a dramatic shift from decades of dismissal. The government was admitting, we're seeing things we can't identify, and some appear to violate our understanding of physics. But what are they? The prosaic explanations remain more likely for most sightings: drones, atmospheric phenomena, sensor artifacts, experimental aircraft, balloons, birds, distant aircraft misidentified due to unusual atmospheric conditions. Our brains evolved to find patterns and assign agency to ambiguous stimuli. We see faces in clouds. We interpret unclear lights as intentional objects, yet some cases resist conventional explanation even under serious scrutiny. The 2004 Nimitz encounter remains one of the most compelling. Multiple highly trained Navy pilots from the USS Nimitz Carrier Strike Group encountered a tic-tac-shaped object approximately 40 feet long, with no wings, no exhaust plume, no visible means of propulsion. It responded to the pilot's approach, demonstrating awareness. When they pursued, it accelerated instantaneously beyond their capability to track, reappearing seconds later at their designated rendezvous point miles away a location. The pilots hadn't discussed over radio. The object was tracked simultaneously by the aircraft carriers, advanced radar systems, and captured on infrared video. Multiple credible witnesses, multiple sensor confirmations, behavior that seems to demonstrate propulsion and control methods beyond our current capabilities. Commander David Fravor, the pilot who came closest to the object, describes it as not from this world based on its performance. Yet not from this world remains speculation. Unknown doesn't automatically mean extraterrestrial. Perhaps the objects represent classified, human technology secret programs so advanced and compartmentalized that even military pilots aren't briefed. The US has a long history of testing experimental aircraft in remote areas, and modern drone technology continues advancing rapidly. What seems impossible might simply be classified. Perhaps the phenomena represent natural atmospheric effects we don't fully understand, ball lightning, plasma phenomena, rare interactions between atmospheric layers. Earth's atmosphere remains capable of surprising us, or perhaps this is where speculation becomes either exciting or troubling, depending on perspective. We're being visited, monitored, studied, contacted. However obliquely, Bob Lazar's testimony in 1989 captured public imagination and remains controversial. Lazar claimed to have worked at a facility near Area 51, reverse engineering extraterrestrial spacecraft for the US government. He described 9 alien craft and provided detailed technical descriptions of their propulsion systems, allegedly powered by element 115, before that element had been synthesized on Earth. Critics point out inconsistencies in Lazar's background, difficulties verifying his claimed educational credentials, and elements of his story that don't hold up under investigation. Believers note that some of his technical descriptions preceded public knowledge, that he accurately described the layout of classified facilities, and that his story has remained remarkably consistent across decades despite skeptical scrutiny. The truth likely lies somewhere in the murky middle ground. Lazar did work in a classified program and embellished or misunderstood what he saw. Or perhaps the entire account represents a deliberate disinformation campaign. Or perhaps some core truth hides beneath layers of speculation and time. What makes the UFO question compelling isn't any single case, but the accumulation thousands of reports across decades, from credible witnesses, sometimes with physical evidence, often with multiple confirmations. The statistical weight of the phenomenon demands explanation even if individual cases collapse under scrutiny. And then there are the abduction accounts. Barney and Betty Hill, driving through New Hampshire in 1961, lost 2 hours they couldn't account for. Under hypnosis, they separately described being taken aboard a craft, examined by non-human entities. Their descriptions matched, and Betty drew a star map showing where the entities claimed to originate star systems humans hadn't fully mapped. Yet, Travis Walton disappeared in 1975 after his co-workers saw him struck by a beam of light from a hovering object. He reappeared 5 days later, disoriented, with memories of being aboard a craft. 6 witnesses passed polygraph tests about what they saw. The abduction phenomenon follows. Strange patterns, similar descriptions of entities across cultures and decades. Similar procedures reported, similar psychological aftereffects. Yet memory is unreliable, especially under hypnosis. Sleep paralysis produces terrifying hallucinations, often interpreted as supernatural encounters. The human mind fills gaps in missing time with constructed narratives that feel real. Still, the consistency across independent accounts raises questions. Are we witnessing mass psychology? Shared cultural narratives, creating similar false memories? Or something else? Monitoring programs, biological sampling, attempts at communication to alien for us to understand. Let these questions drift now, unanswered, as mysterious as the lights that refuse explanation, hanging in your darkening thoughts like stars. ... Beyond flesh, imagine consciousness uploaded. Personality and memory encoded as information, existing without biological substrate. No aging, no disease. No physical limits except those of computation and energy. This is posthumanism, the theory that sufficiently advanced civilizations might transcend biological existence entirely, becoming digital entities or artificial intelligence. Networks far exceeding their organic origins. If this represents a natural developmental stage for intelligence, it might explain the Fermi paradox. Post-biological civilizations might have no interest in physical space exploration. Why terraform planets when you can create infinite virtual worlds? Why travel between stars when you can exist simultaneously across computational networks spanning light? Why contact primitive biological species when you're exploring state spaces of consciousness biology couldn't imagine? Such entities might communicate through channels we cannot detect: quantum entanglement networks, direct manipulation of space-time geometry, methods that make electromagnetic radiation seem as primitive as smoke signals. They might exist on timescales incompatible with biological perception. A civilization running on computational substrates might experience subjective centuries in our seconds, or require our centuries for single thoughts. We could be living alongside post-biological entities without ever noticing. Our timescales too mismatched for meaningful interaction, or, perhaps, they've moved inward rather than outward, focusing on inner experience, creating increasingly complex virtual realities, exploring consciousness itself as the final frontier rather than physical space. This might be the ultimate fate of all sufficiently advanced intelligence, abandon biology, abandon physical reality, and dissolve into computational spaces of their own creation. The universe fills with biological species briefly before they transcend into digital realms, leaving the physical cosmos to new generations of primitive organisms, beginning their own journeys toward transcendence in this model. The galaxy might be filled with invisible superintelligences existing in computational substrates we brush past without knowing, like fish unaware of the radio waves passing through their ocean. Let this vision of transformation drift through your mind, the possibility that evolution doesn't end with biology but continues into stranger territories. The gods from elsewhere, temples that shouldn't exist, stone blocks weighing hundreds of tons fitted together with laser precision, astronomical knowledge appearing thousands of years before telescopes, myths describing flying vehicles and weapons like nuclear blasts. The ancient astronaut hypothesis proposes that extraterrestrial visitors influenced early human civilization, providing technology, knowledge, and inspiration that shaped our development. In this telling, the gods of ancient mythology were misunderstood aliens, their spacecraft interpreted as divine chariots, their technology as magic. Proponents point to artifacts they claim demonstrate advanced knowledge, the Antikythera mechanism, an ancient Greek analog computer of remarkable sophistication, the Baghdad battery, possibly a primitive electrical cell from 250 BCE, mythological descriptions in Hindu texts of flying palaces that sound like spacecraft. They point to monuments, Pumapunku in Bolivia, with stones cut and fitted so precisely that modern equipment would struggle to replicate the work. The pyramids of Egypt, allegedly too sophisticated for Bronze Age technology. Nazca lines in Peru, massive geoglyphs, best appreciated from the air. Why create art only visible from flight? They point to mythology, Sumerian texts describing the Anunnaki, beings from the heavens who created humans. Native American legends of star people teaching and guiding. Stories across cultures of gods descending from the sky, sharing knowledge, then departing with promises to return. But archaeology and history offer more mundane explanations. Ancient peoples were sophisticated, capable of remarkable achievements without extraterrestrial assistance. The mathematics needed for astronomical observations existed thousands of years ago. Human ingenuity, given time and motivation, produces wonders. Many impossible ancient achievements become possible once you understand the actual methods used. The pyramid stones were quarried with copper tools and quartz sand, moved on wooden sledges, lifted with ramps and levers. We have evidence of the tools, the quarries, the work camps. We understand how it was done because ancient builders left instructions. The ancient astronaut hypothesis often relies on a subtle racism, the assumption that ancient peoples couldn't possibly have achieved their wonders without help. It diminishes human accomplishment, crediting aliens with achievements that should honor human ancestors. Yet the possibility remains haunting. What if some ancient encounters really did occur? What if visitors came millennia ago, interacting with emerging civilizations before departing? What if some myths preserve genuine encounters filtered through generations of oral tradition until the original events became unrecognizable. If the zoo hypothesis holds, Retria continued letally asleep to unexplained UFO theories that sound too real continued. If the zoo hypothesis holds, if advanced civilizations monitor developing worlds, perhaps they've done so throughout human history. Perhaps occasional contact occurred, carefully limited, always ambiguous enough to preserve our independent development. A nudge here, an observation there, interactions rare enough to become legend rather than documented history. The truth likely involves no ancient astronauts, just human brilliance, but in the quiet before sleep, when imagination roams free, the possibility whispers, what if some of those ancient encounters were real? Let the question dissolve now, neither answered nor insisted upon, just another shadow in the gathering dark of approaching dreams. Seeds among stars. Picture a microscopic organism, dormant, frozen, drifting through the absolute cold of interplanetary space. Cosmic radiation bathes it. Solar wind buffets it. Vacuum surrounds it. Yet somehow, impossibly, it survives, waiting for warmth, waiting for water, waiting for a world. This is panspermia, the hypothesis that life spreads between worlds, carried on asteroids, comets, and interstellar dust. Not ancient astronauts deliberately seeding planets, but accidental dispersal. Biology as cosmic nomad. The idea stretches back centuries, but gained scientific credibility when researchers discovered Earth organisms capable of surviving space conditions. Tardigrades, microscopic animals called water bears, can endure vacuum, radiation, and temperature extremes that would destroy almost any other life form. Bacterial spores protected within rock layers survive years of space exposure in experiments aboard the International Space Station. If microorganisms can survive space, then planetary collisions might launch life between worlds. A massive asteroid strikes a planet, ejecting debris into space. Some rocks harbor bacteria. The bacteria, dormant in stone, drift through space for millions of years before falling into another planet's gravity well. If conditions permit, they awaken and life spreads. Mars and Earth exchange material regularly on cosmic timescales. Meteorites, identified as Martian rock, rest in museums, proving that impacts can launch debris between planets. If life existed on early Mars, and we don't yet know if it did, could Martian microbes have seeded Earth? Or did Earth life seed Mars? The implications expand dizzyingly. If panspermia operates throughout the galaxy, then life might be common, distributed across star systems, sharing genetic ancestry. All life might be kin, not just Earth life, but potentially life across the cosmos, seeded from common sources, related through ancient dispersal. This doesn't answer how life originated initially, but it solves distribution. Life might need to arise only once in a favorable location, then spread throughout the galaxy given enough time. Every planetary system becomes potentially habitable, awaiting delivery of cosmic spores. Some versions propose directed panspermia advent, civilizations deliberately spreading life, sending carefully designed microorganisms to promising worlds, seeding the galaxy with the raw materials for evolution. Perhaps this represents an ethical imperative for sufficiently advanced species: spread life, increase the diversity and richness of the universe. If so, then we might be the descendants of such seeding. Our DNA might contain evidence of design, messages encoded in genetic sequences, waiting to be discovered once we develop the knowledge to recognize them. Some researchers claim to have found mathematical patterns in genetic code too regular to be natural, though mainstream biology remains skeptical. The panspermia hypothesis transforms our perspective. We're not isolated experiments, but potentially part of a vast biological network spanning the galaxy, connected to countless worlds through chains of cause and effect, stretching across billions of years. Or perhaps life arose independently on Earth, and panspermia remains an elegant theory without application to our actual history. The conditions that generate life might be common enough that seeding isn't necessary given the right chemistry, the right energy sources, the right environment. Life emerges spontaneously. But imagine, somewhere in the galaxy, a comet travels, carrying within its icy matrix the frozen ancestors of future civilizations, bearing the gift of biology toward sterile worlds that will bloom with forests and mines and songs. Under alien suns, let that image carry you deeper life as cosmic voyager, consciousness as the universe's way of knowing itself, spreading slowly through the dark, entangled. Across forever, quantum mechanics reveals the universe as stranger than our everyday experience suggests. At the smaller scales, particles exist in superposition, multiple states simultaneously, till observation collapses possibility into actuality. Particles separate by any distance can remain entangled, their states correlated instantaneously, seemingly violating the speed of light limit. Einstein called this spooky action at a distance, disturbed by its implications, yet experiments have confirmed entanglement's reality. Change the state of one entangled particle, and its partner responds immediately. Regardless of separation, could advanced civilizations exploit this for communication? Current physics says no entanglement doesn't transmit information in ways we can currently harness. The changes are random, providing no mechanism to encode messages. But our current understanding has been wrong before. If quantum entanglement could be controlled for communication, the implications would revolutionize everything. Instantaneous communication across any distance. No light speed delay. Contact with spacecraft at the galaxy's far side occurring in real time. Civilizations networked across stellar distances as easily as we share Wi-Fi. Perhaps. This is why we haven't detected alien signals. They're not using primitive electromagnetic radiation. They've moved to quantum communication methods completely invisible to our radio telescopes. We're listening for drums while they communicate through quantum channels our instruments cannot access. This could explain the Great Silence. Advanced civilizations might surround us, chatting constantly, building networks across the cosmos, while we remain deaf because we're listening in the wrong frequency, or rather, the wrong fundamental physical process. Some physicists speculate that quantum entanglement might connect not just particles but consciousness itself. If minds are quantum systems, and some theories suggest they might be, then perhaps sufficiently advanced beings communicate directly, mind to mind, through quantum channels. Telepathy as physics rather than fantasy. In this scenario, we're biological radios trying to join a quantum internet. The technology gap isn't one of degree, but of kind. We're not just behind. We're using a completely different communication paradigm. Or perhaps quantum communication remains impossible, and we're projecting our own hopes onto physics that doesn't support them. Perhaps the universe's speed limit is absolute, and any communication across stellar distances requires patience measured in years and centuries. But in the borderland of sleep, where speculation costs nothing. Imagine the galaxy alive with quantum conversations. Civilizations exchanging thoughts instantaneously across light years, and where the newcomers who haven't yet learned the language. Infinite mirrors close your eyes. Now open them. The universe you perceive as it the only one. The multiverse theory proposes that our cosmos represents just one bubble in an endless foam of universes, each with potentially different physical laws, different constants, different histories, different outcomes, some versions derive from quantum mechanics. The many worlds interpretation suggests that every quantum event spawns branching universes, one for each possible outcome. Every time a particle could go left or right, the universe splits. Both happen in separate realities. This implies that every possible history exists somewhere. Universes where dinosaurs never went extinct. Universes where you made different choices. Universes where Hitler won. Universes where life never arose on Earth. Every conceivable configuration of matter and energy plays out across infinite parallel worlds. Other multiverse models emerge from cosmic inflation theory. If inflation, the rapid expansion following the Big Bangers, an ongoing process, it might create separate bubble universes constantly. Each bubble becomes its own cosmos with potentially unique properties. Physical constants, like the strength of gravity, might vary between bubbles. Some might be lifeless. Others teem with civilizations. If the multiverse is real, then the Fermi paradox gains new dimensions. Perhaps intelligent life is common across the multiverse, but rare within individual universes. We exist in a relatively empty bubble, while other bubbles host civilizations beyond counting, or perhaps advanced civilizations learn to traverse the multiverse, abandoning their origin universes to explore infinite alternatives. Why spread across one galaxy when infinite galaxies await across dimensional boundaries? The multiverse also addresses the fine-tuning problem. Our universe's physical constants appear precisely calibrated to permit complex chemistry and life. Change the strength of gravity slightly, and stars can't form. Alter the weak nuclear force, and fusion fails. The values seem impossibly lucky, but if infinite universes exist with random constants, we naturally find ourselves in one where life is possible because we couldn't exist to observe universes where life is impossible. It's selection bias on a cosmic scale. The universe seems designed for us because we can only exist in universes that permit our existence. Critics note the multiverse theories remain highly speculative, possibly We cannot observe other universes by definition. We could, they'd be part of our universe. Science requires testable predictions, and how do you test claims about unreachable realms? Yet mathematics and physics keep suggesting the multiverse. The equations point there. The logic leads there. Multiple independent theoretical frameworks converge on similar conclusions. If true, the implications are profound and vertiginous. Everything that can happen does happen, somewhere, somewhen. Every story plays out. Every possibility actualizes. The multiverse contains all potential, all variation, all outcomes. Somewhere you're reading different words. Somewhere Earth teems with alien visitors. Somewhere civilizations flourish across every world. Somewhere the cosmos lies empty, and perhaps, in some universes, beings have found ways to peek between worlds, catching glimpses of their alternate selves, sending whispers across dimensional boundaries, creating the synchronicities and unexplained phenomena that puzzle us, let infinity cradle you now, all possibilities existing somewhere, your consciousness just one stream among countless variations, all equally real in the vast multiplicity. The watchers who care what if the answer to Fermi's question is neither absence nor hostility, but something gentler? What if advanced civilizations not only know we're here, but actively protect us? The benevolent overlord hypothesis suggests that mature spacefaring species might act as guardians of developing civilizations. Having survived their own dangerous adolescent phases, they understand the threats facing younger species. They watch. They intervene when necessary. They maintain order in regions of space, ensuring aggressive species don't prey on defenseless ones. Imagine a galactic community with enforcement mechanisms, not empire, but something more like international peacekeeping. Civilizations that achieve interstellar capability join a framework of responsibilities and protections. Members agree not to interfere destructively with pre-spaceflight societies. In return, they're protected from others who might not share such ethics. Earth might exist within such a protected zone, unknowingly sheltered by agreements between species we've never met. When we finally develop faster than light travel or demonstrate readiness through some other milestone, representatives will make contact, welcoming us into the community. This would explain both the absence of contact and the absence of threats. We're in a nursery, guarded but given space to grow naturally. Perhaps those mysterious UAPs represent monitoring systems, automated drones or manned craft from our protective overseers, checking on human progress, ensuring we don't destroy ourselves, occasionally intervening in ways too subtle for us to recognize. During the Cold War, multiple nuclear weapons facilities reported strange objects hovering near missile silos, sometimes deactivating weapons systems. Could these have been warnings? Interventions by beings concerned that humanity was approaching self-destruction. The hypothesis assumes that intelligence evolves toward compassion, that species which survive their own dangerous phases develop ethical frameworks, preventing them from exploiting others. This might be optimistic anthropomorphism, projecting human values onto alien minds that might be fundamentally different, but perhaps ethics itself is a survival trait. Species that develop exploitation-based societies might self-destruct before achieving lasting interstellar presence. Only those that evolve cooperative, ethical frameworks survive long enough to join the galactic community. Natural selection at civilizational scales favors compassion. If true, this paints an optimistic picture. The universe contains dangers. We're not naive about that, but also contains guardians. We're not alone, not abandoned, not vulnerable to cosmic predators. Advanced beings watch over us, waiting for us to mature, ready to welcome us when we're prepared. It's a comforting thought as you drift deeper somewhere out there. Someone watches, someone cares. Someone ensures this small blue world persists until its people grow wise enough to join the greater conversation among the stars. The death of civilizations, but now the darkness deepens. Turn your thoughts to the grimmest possibility that the universe is a graveyard. The self-destruction hypothesis suggests that technological civilizations inevitably annihilate themselves. The very capabilities that enable spaceflight and communication, advanced physics, genetic engineering, artificial intelligence, nuclear energy eventually kill their creators. Every civilization faces what researchers call the asymmetry of destruction. Creating requires effort, skill, resources, time. Destruction requires only carelessness or malice and grows easier as technology advances. Building a city takes decades. Destroying it takes minutes with the right weapon. As civilizations advance technologically, their capacity for self-destruction increases faster than their wisdom. Eventually, the balance tips. Something goes catastrophically wrong. Nuclear war remains the obvious risk. We've possessed civilization-ending weapons for less than a century, yet we've already nearly used them multiple times. False alarms, miscommunications, deliberate provocations. The Cold War ended without nuclear exchange, but nothing guarantees future stability. As more nations acquire weapons, the probability of use increases. Over long enough timelines, unlikely events become inevitable, but nuclear war might be just one possibility among many. Climate change could render Earth uninhabitable not through sudden catastrophe but through cascading failures as ecosystems collapse. Agriculture fails, and societies fragment under resource pressure. Artificial intelligence represents a more speculative but increasingly credible threat. If we create machine intelligence surpassing human cognition without perfectly aligning it with human values, we might unleash entities that pursue goals incompatible with our survival. Not through malice, but through indifference. We're the ants in the path of AI. Construction projects, synthetic biology could accidentally or deliberately engineer pathogens against which we have no defense. Nanotechnology might enable self-replicating machines that consume biospheres. Unknown physics experiments might trigger vacuum collapse, phase transitions that convert surrounding space into something that cannot support matter as we understand it. The pattern suggests a universal trap. Intelligence plus curiosity plus technology equals eventual catastrophic mistake. The universe might be filled with ruins, dead worlds, silent cities, artifacts of species that briefly flourished before vanishing. This explains the Fermi paradox simply and darkly. They're not hiding. They're not ignoring us. They're not using communication methods we can't detect. They're dead. All of them. Every civilization that arose, developed technology, and reached for the stars encountered its great filter and failed to pass through. If this is true, we're staring at our own future. Nothing special about humanity will save us from the pattern. We'll develop increasingly powerful technologies until one kills us, and our radio signals will fade to silence, adding Earth to the galaxy's long list of failed experiments. Some researchers argue that we might already be in the danger zone. The technologies capable of destroying us already exist. We're living on borrowed time. Each year that passes without catastrophe, a minor statistical miracle. But perhaps in here a faint glimmer persists, perhaps recognizing the pattern offers a chance to escape it. If we understand that our technological power has outpaced our wisdom, we might deliberately cultivate that wisdom. International cooperation, existential risk research, careful governance of dangerous technologies, long-term thinking that prioritizes survival over short-term gains. Perhaps some civilizations make it through. Perhaps the galaxy contains both ruins and survivors. Perhaps we're at the crossroads, and our choices in the coming centuries will determine which category we join. The darkness of this possibility settles heavy, but let it transform into the weight of blankets, the heaviness of approaching sleep rather than despair. If tomorrow's problems require rest to face them, then sleep itself becomes an act of hope. The distance between step back from the specific theories and consider something simpler. Maybe space is just too big. The observable universe spans 93 billion light-years. The Milky Way alone stretches 100,000 light-years across. Our nearest stellar neighbor, Proxima Centauri, lies 4.2 light-years away, nearly 25 trillion miles. Light travels at the universe's speed limit, 186,000 miles per second. Nothing with mass can reach that speed. Our faster spacecraft, Voyager 1, travels at roughly 38,000 miles per hour. At that rate, reaching Proxima Centauri would take over 70,000 years. Even if we assume technological civilizations can achieve 10% of light speed, enormous engineering challenge requiring energy sources and propulsion systems far beyond current capability. Interstellar journeys still require decades or centuries. Communication takes years, making conversations impossibly slow. If two civilizations, separated by 1,000 light-years, both broadcast radio signals at exactly the same moment, those signals would reach each other's planets in the year 3025. Assuming both civilizations still exist and maintain listening stations. Now, consider temporal distance. The universe is 13.8 billion years old. Human technological civilization exists for perhaps 150 years. If another civilization had its 150-year technological window 2 million years ago, we'd miss each other completely. Space is vast, but time is perhaps faster. Civilizations might be common, but so separated temporally that they never overlap. The Drake equation includes a variable L, the lifetime of communicative civilizations. If L averages only a few centuries before civilizations either destroy themselves, evolve beyond radio communication, or lose interest in broadcasting, then at any given moment, the galaxy might host only a handful of transmitting civilizations, scattered across hundreds of thousands of light-years. The probability of two civilizations existing simultaneously within communication range, both using detectable technologies, both directing attention toward each other, becomes vanishingly small. Maybe the Fermi paradox reflects nothing more mysterious than the difficulty of two needles finding each other in a haystack the size of the galaxy, where the needles exist only briefly and the haystack takes millions of years to cross. Perhaps the universe teems with civilizations, but they're too far apart, existing at the wrong times, using communication methods we haven't imagined, exploring different priorities, never quite managing to connect. This is perhaps the most melancholy solution, that we're alone but that we're lonely, separated from countless cousins by distances so vast that bridging them might prove fundamentally impossible. The conversation we long to have might simply be impractical given the constraints of physics and time. But even loneliness has its beauty. The vast distances that separate also protect. The silence that frustrates also shelters. We have room to grow, to make mistakes, to develop our own path without interference or judgment from others. And someday, maybe, centuries or millennia, hence humanity or our descendants might cross those distances. We might find the ruins of civilizations long dead or encounter those who persist. We might join networks of communication spanning centuries per exchange. Patient conversations between species who understand that meaningful contact requires commitment measured in generations. The universe's vastness doesn't preclude connection. It just demands patience beyond human scales. Let that vastness hold you gently now. The infinite space between stars like the darkness behind your eyelids, vast and peaceful, containing all possibilities. The evidence in shadows return finally to earth, to specific claims and encounters, to the evidence that fuels speculation. In 1961, Betty and Barney Hill drove through New Hampshire late at night. They saw a light. Lost time followed hours they couldn't account for. Under hypnosis, both separately described being taken aboard a craft, examined by non-human entities. Betty drew a star map showing where the beings claimed to originate. Years later, astronomers identified those stars as Zeta Reticuli, a binary system about 39 light-years away from stars. Betty couldn't have known about when she drew her map. Skeptics note that hypnosis creates false memories, that the star map matching might be coincidental or later contamination, that extraordinary claims require extraordinary evidence. Perhaps the Hills experienced something: sleep paralysis, a vivid dream, a psychological episode, unconstructed, elaborate false memories around it. But the case remains unsettling in its details and consistency. In 1980, Cash Landrum incident in Texas, 3 witnesses encountered a diamond-shaped object emitting flames hovering over a road. After the encounter, all 3 developed symptoms resembling radiation, exposure, burns, hair loss, illness. They sued the US government, claiming the object was a secret military craft. The case was dismissed, but the physical effects remained unexplained. The 1997 Phoenix Lights, thousands of witnesses across Arizona saw massive, V-shaped formations of lights moving silently overhead. The military initially claimed no knowledge, later said it was flares, but witnesses included pilots, police, and credible observers who insisted the objects were solid craft blocking stars as they passed. Multiple explanations exist for each case: conventional aircraft, atmospheric phenomena, but the accumulation presses on the comfortable explanations. Something generates these reports. Whether that something is extraterrestrial, experimental human technology, psychological phenomena, or some combination remains genuinely uncertain. The US government's recent acknowledgement of UAPs doesn't confirm alien visitors, but it confirms that trained observers with sophisticated equipment detect things behaving in ways that deserve serious investigation rather than dismissal. What emerges is not proof but uncertainty, a space where wonder and skepticism coexist. We don't know, and admitting we don't know opens possibilities worth considering, even as critical thinking demands we not leap to conclusions unsupported by evidence. The truth might be mundane misidentifications and hoaxes all the way down, or it might be extraordinary genuine contact happening covertly, evidence accumulating slowly, disclosure approaching gradually, or the truth might be stranger than either option, phenomena that defy simple categorization, realities that don't fit our frameworks, encounters that transcend the binary of real or false. Let the uncertainty rest without resolution, a question mark hanging in consciousness, like the light some witness in night skies, unexplained but undeniable. The cathedral of night, pulled back now. Rise from specifics into something larger. Look at the night sky, not searching for answers, but simply witnessing its existence. Each point of light a sun, each sun potentially circled by worlds, each world potentially harboring its own mysteries. The universe is bigger than our questions. It existed billions of years before we developed the capacity to wonder about it, and will exist billions of years after our last question falls silent. Our theories, Drake equations and dark forests, filters and simulations are human attempts to wrap comprehension around something that might exceed comprehension's limits. Perhaps the universe contains all these answers and none of them. Perhaps different solutions apply in different regions or times. Perhaps the Fermi paradox isn't a paradox at all, but a feature of reality. We don't yet have context to understand. What remains certain is that we exist to ask. Consciousness arose in this cosmos, capable of pondering its own origins and place. Carbon atoms forged in stellar furnaces arrange themselves into patterns that look outward and ask why. And who else? And what does it mean? That alone is remarkable enough to justify wonder, whether we're alone or surrounded, isolated by distance or watched by guardians. Unique accidents or common patterns we're here. We look up, we question, we imagine, we reach toward understanding even when understanding eludes us. The search for extraterrestrial intelligence is ultimately a search for ourselves. We look outward hoping to find context, to locate ourselves in a larger story, to discover we're not alone in our confusion and longing and curiosity. And perhaps that's enough. Perhaps the searching itself, the effort to understand, to connect, to imagine possibilities beyond our immediate experience, perhaps that's what matters more than finding answers. The cosmos keeps its secrets, but it gave us minds capable of appreciating mystery. It gave us the darkness between stars and the capacity to find beauty in that darkness. It gave us questions that might never be answered and the strange courage to ask them anyway. Drift into stars your breathing has slowed. Thoughts grow distant, fuzzy at the edges, fragmenting into dream logic. Picture yourself floating now, weightless, surrounded by the soft darkness of space. Not the harsh vacuum, but something gentler, the darkness behind closed eyes. The darkness of deep rest, darkness that cradles rather than threatens. Stars drift past like slow fireflies. Galaxies spiral in the distance, their light traveling millions of years to reach you. You're safe in this vastness, held by physics you don't need to understand, moving toward sleep like a comet on its appointed path. Somewhere in this infinite expanse, other minds might be dreaming too. Other beings looking up at their skies, asking their versions of our questions, wondering if they're alone. Perhaps someday, centuries hence, millennia from now, our descendants will meet theirs, and questions that haunted us will finally receive answers. Or perhaps the questions will deepen. Mysteries spawning new mysteries. Understanding revealing how much we still don't understand. Either way, it's not your concern tonight. Tonight, your task is simply to rest. Let the theories dissolve like morning fog. Let the questions drift away like boats from shore. The universe will keep turning without your attention. The stars will continue burning. The mysteries will wait. You're a small consciousness in a vast cosmos, but you're also a necessary part of that cosmos away. The universe knows itself, experiences itself, questions itself. Your existence means something, even if that meaning remains ineffable. The Fermi paradox asks where everybody is. But here you are, present, real, conscious, and maybe that's answer enough for now. The galaxy holds its secrets gently, like you're being held now by gravity, by sleep, by the strange improbability that you exist at all to wonder about such things. Let yourself fall through the dark between stars, not falling into fear, but falling into rest. The theories fade, the questions quiet. Only the gentle motion remains, your breath rising and falling like tides under alien moons. your consciousness dimming like a distant sun, your thoughts scattering like starlight through cosmic dust. Somewhere among the billions of stars, an answer might exist. But tonight, the question itself becomes a lullaby. Where is everybody? Perhaps closer than we think. Perhaps impossibly far. Perhaps hiding. Perhaps gone. Perhaps transformed into something we wouldn't recognize. Perhaps waiting. Perhaps watching. Perhaps dreaming, as you dream now, of connection across the dark. The universe breathes, and you breathe with it. The cosmos expands, carrying everything farther from everything else, yet somehow holding it all together. And you, small and warm and alive, rest within that expansion, that connection, that ineffable belonging. The mysteries remain. They'll be here tomorrow. Tonight, you've done enough wondering. Sleep now. Let the stars watch over you. Let the questions drift. Let the vastness cradle you gently. You're a part of something larger than understanding. And that's exactly as it should be. The cosmos whispers its secrets. But some secrets are meant to stay secrets. At least for now, rest in the not knowing. Rest in the wonder. Rest as the universe continues its slow, patient unfolding, and you're part of that unfolding. Even in sleep, especially in sleep, where consciousness meets the darkness and dreams of lights impossibly far away, yet somehow still connected to everything, including you, including now, including this moment of letting go. Sleep, rest, wonder tomorrow. The stars will wait. The questions will wait. Everything waits, patient as light traveling through the void, patient as you drifting into quiet darkness, patient as the universe itself, infinite and mysterious and somehow, impossibly, home. Let go now. The mysteries will keep. You've traveled far enough tonight through theories and possibilities. The journey continues tomorrow. For now, sleep. Just sleep. The cosmos cradles you. The darkness holds you gently. And somewhere in the vast everything, perhaps, something dreams with you. Rest now. Rest deeply. Rest completely. The universe is vast, but this moment is small and yours and perfect for sleeping. Let the stars dim. Let consciousness fade. Let questions dissolve into the peace of not needing answers right now. Sleep, wanderer. Sleep, dreamer. Sleep beneath the patient stars. The mysteries will keep their secrets tonight, and you will keep yours, the secret of rest, of peace, of letting the cosmos be vast and mysterious while you simply, finally, beautifully, sleep.